All right, hello people watching this video. I have lots of papers that I just gave to you, or if you don't have the papers, you need to come get them. There's lots of papers. We're going to start with this paper right here, and we're going to deal with just this guy and his backside, which has the formulas on it that we will need, okay? So, one on my desk. So, those things, just this page, just deal with him right now, set the other ones off to the side, and we will maybe come to them later on. Another thing... No, you don't need that yet either. Okay, so we're just going to go through this example. Here is your overview of hypothesis testing. I love this chapter. This chapter and chapter 6 are like my favorite chapters. Okay, we went through chapter 6. You didn't get as excited about it as I did. But anyway, chapter 8, I really feel like we're actually doing stuff. Okay, so here's the deal. I'm going to do some hypotheticals here, and I'm going to write some stuff down, and you don't write this down. Okay, but I'm just going to give you an example of what we're doing, right? Okay. So let's say that I have a person, or I am a pharmaceutical company, and I am trying to test a blood pressure medication, okay? Trying to test a blood pressure medication. And the person that I am testing the blood pressure medication on, to start with, has a blood pressure that is, let's say, 134/88. That's a true blood pressure. I took my friend's blood pressure the other day, and it's high. 134/88. That's his blood pressure, okay? And my blood pressure medication to him brought his blood pressure down to 130/85. It worked, right? It worked. It brought both the top and the bottom number down, so like hypertension is like down a little ways. But that's still kind of in dangerous mode, right? Like, that's still a little high for a blood pressure, okay? So what we're doing when we're hypothesis testing is we're saying, okay, that's great. It brought it down, but was it a significant amount, or was it enough to say that your blood pressure medication is good and we should make people pay for it? Does that make sense? Like, if I'm going to put this out on the market, yeah, I can say that it's effective, but is it enough for people to pay for it, right? Or enough for it to be like deemed good, right? So that's what we're kind of looking at here when we're doing hypothesis testing. I'm going to go through this example that they give to us that's talking about M&Ms, a little bit lighter of a topic, and we're going to go through just the first couple steps of this, okay? I'm going to just give this to you in little chunks. And it's going to take us probably like 3 days to get through section 8.1, okay? Just because it's a lot. When we're doing hypothesis testing, take a look at all these. How many steps do you see all the way through the page? 8. But this will become so second nature to you that the steps will just flow, okay? I promise you. You will know exactly what you're doing, okay? So I'm just going to go through the first couple steps with you to see, just to give that to you, and then I'll give you a homework assignment for like 4 problems. Just do that part. We'll just do it a little bit in chunks, okay? So here's what we're looking at, and I'm going to write down some information that we have. From data set 27, whatever, M&M weights in Appendix B, it lists data from 100 M&Ms, and 27% of them are blue, okay? 27% of them are blue. So we're talking about blue M&Ms. I'm going to put blue off to the side over here. And if we use the percentage 27, what variable do we usually associate with 27 or that percentage? P hat, because it's our sample, right? P hat, and I'm going to write it as 0.27, okay? P hat is 0.27. The Mars Candy Company claims that the percentage of blue M&Ms is equal to 24%, okay? So in this case, P is what the overall population, like the Mars Candy Company is saying that all of the M&Ms, every single one of them, if we were to survey that, it would be 24% or 0.24. Now that's not what I got as a number, right? I got 27% for my sample, right? They said 24%. 27% is not the same thing as 24%, but is 27% close enough to 24 to say that, like, okay, you know, that's fine, right? Okay, here's my question to you though. What percentage would it have to be in order for you to be like, wait a second, that's false advertising? What percentage would that have to be?
100%.
You would say 100% blue M&Ms?
Yeah.
I wouldn't have to be that high for me. I would say anything above like maybe 35%, right? Like 35% is the threshold for me. If I had more than 35% blue M&Ms, I would be like, I don't know if this 24% is quite accurate, right? Okay, again, we're talking about blue M&Ms, so it doesn't really matter. But if we're in the pharmaceutical world, you better believe these percentages make a difference in people's health, right? Okay, so this is kind of like how we're doing things, okay? If it was like 34%, if my number, don't write this down, but if this was actually 35%, I would be like, I don't know if they should go out and advertise 24%, right? They should just maybe keep quiet and not say anything about their percentage of blue M&Ms. I don't know, right? 35% is a lot different than 24%. So that's what we have to decide. Yeah, it's off, like they're not the same number, but are they significantly different from one another, right? Okay, and that's what we have to decide. All right, use a significance level of 0.05. They used to say a confidence level, and they would go 90-some%, right? This is the same thing as 95% confidence, right? On your little laminated sheet, the Z one that's down in the corner, do you guys remember like 95% off to the side of that, they would have this little fish looking thing, and it was 0.05?
Yep.
Now, rather than giving me the 95%, they're going to give me the fish instead. But just know that those are the same thing, right? They're going to write it as a significance level. The only reason why they do it that way is because we're not making a confidence interval. We're not doing a 95 confidence interval. We're looking at the significance of it, okay? So they will just present it in a different way. 0.05 is the significance level, all right? And that's all the information they give to me. Should the Mars company take corrective action? Should they figure out what's going wrong with their assembly line that's making significantly more blue ones? Should they change this number, right, to be a little bit higher? Should they do that? Again, we're talking about M&Ms, so I don't know that it really matters. But if this is a drug company, should we take action? Do we need to do something? Okay. So, steps 1, 2, 3. There's a lot of stuff that you're doing. Some of the stuff we've already done, we've collected the information that we need. We're doing hypothesis testing, and when you do hypothesis testing, there will be a null. Underline these words. A null hypothesis, which they write as H. And it looks like a 0. That's H0 or H0. That means your initial hypothesis, right? H0, H0, okay? We will always have an H0 and then an alternative hypothesis, which is H1. Sometimes they will call H1 HA instead, but those mean the same thing. I will always use H1, but if you see that, that means the same thing. Your alternative hypothesis. H0, H1, okay? Good? All right, so here's the deal. We have a null hypothesis, an alternative hypothesis. We are talking about P's here, right? We're doing P. Eventually, we'll get to the point where we'll do mu, and then for standard deviation, we'll do sigma, right? Those are the variables that you're going to use, those 3, right? We're either using P, mu, or sigma. I'm going to write that off to the side over here. P is proportion. Mu is for mean. Sigma is for standard deviation. I don't think I ever make you do variance, but anyway, so there's those. All right, so for right now, we're talking about P. And here is the rule. Here is the rule. Your first P, wait, was that your wait? Oh, yeah. Okay, your null hypothesis will always be P equals something, right? Your alternative hypothesis is what the difference will be, okay? So the candy company is claiming that P is equal to how much? 0.24. So we're going to go along with that. We're going to say, okay, initially we're going to say that the hypothesis is that P is exactly 0.24. It's not, but is 27 really high enough to say that they're wrong, right? Are they really wrong by advertising 0.24? Maybe it was just my data set had a significantly high number of blues. I don't know. And then the next one is going to be that P is, let's see, to test that claim, we're going to say in this case that it is not equal to 0.24. Okay, eventually we'll get to a point where we're going to say it's greater than 0.24 or less than 0.24. But here we're going to say that it's not equal to, okay? All right. Now, That's what our null and alternative hypothesis are going to look like. Your first one will always be the equal to one. Your second one will be not equal to or greater than or something like that. I need papers. We need papers. We're just on this paper. Actually, I'll give you the other two because they're sitting right there. Okay, so good. Null alternative hypothesis. Your null hypothesis will always be equal to. Okay. All right. Select the significance level. Step 4. What do we got?
0.05.
Alpha is 0.05, right? Which we said is kind of the same thing as 95% if we're looking on that Z chart, right? Looking at the Z chart is kind of like using 95%, okay? All right, step 5, we have to, when we're looking at P, we have to decide these two requirements must be fulfilled, right? So when I take N times P, it has to be greater than 5, and N times Q has to be also greater than 5. We've talked about that at some point earlier, okay? What is N? We didn't write that down. 100. They did a sample of 100 M&Ms, and they said that 27% were blue, right? So N is 100. All right, so we're going to check off these. We're going to take 100 times P is 0.24, and 100 times Q, what will Q be? 0.76. What's 100 times 0.24?
24.
Just 24, right? Is that greater than 5?
Yep.
Check. 100 times 0.76? Just 76. Greater than 0.5 or greater than 5? Check. So, if that's not true, we can't even do this study to start with because you're talking about extreme values and then we have some weird things going on, okay? So, step 5 says identify the statistics relevant to the test and determine its sampling methods such as normal, T, or X bar, okay? Normal is Z, okay? So if you need to write that down, normal is Z. Sometimes they'll use normal instead of calling it Z, but Z, T, or X bar. Okay, when do we use Z? Like from last chapter, when do we use Z? When we're doing proportions. When we're doing proportions, not talking about means yet. Just wait. We're doing proportions. T is for means, and X bar is, or chi-squared is for standard deviation. These are the charts that you use. Now, sometimes we use Z also for means, right? And that just depends on when we have like X bar, or when we have N greater than 30, less than 30, that type of thing, okay? So, we're doing a proportion here. We're doing P's and P hats. So we're going to use the Z chart, which means like the positive, negative side, you're going to use that bottom corner. That's the only chart that you're going to use, right? Make sense? Okay, so we're going to use Z. That's the one that we're going to use. And we've checked off the requirements in order to do that so we can run this test and we're ready to go. Haha. Okay. All right, let's do this real quick. We know that we're going to use Z, and we know the level of significance is 0.05, or like 95%. What is the Z for 95%? If you look at your chart.
1.6.
1 point. I think it's 96 for 95. Is it? 1.96 for 95? 95. Is it 1.96 for Z? Okay, so here's the deal. We're not going to go very much further except for one more thing. So our Z is 1.96. That's the Z that we're going to use. Okay? And then we have on the back side of this paper, flip this over. Depending on whether we're doing a proportion, or whether we're doing a mean, or whether we're doing a standard deviation, we use this formula for something called a test statistic. We have to use something that we're comparing to, right? We're comparing a number to another number, like the 27% we're comparing to the 25% or 24%. We have a test statistic. This is the formula that we're going to use to calculate our test statistic, which we call Z. Okay, it's kind of confusing because we have a Z up here, but this is what we're going to compare to. This is our comparing Z. We're going to compare the number that we got to the 1.96, okay? This is the formula that we're going to use. Write this down off to the side over here. And the next one This is the last thing we're going to do, and then I'm going to stop you. And then I'm going to give you something to do. Because I don't want to overload you. Right? MJ, are you already overloaded?
Yeah.
Sure. Okay. All right. P hat minus P over the square root of PQ over N. This is the Z that we're going to calculate. It's always this formula for proportions. Okay? We've labeled stuff up at the top. Which one is P hat? 0.27. That's my number. The sample that we got said 27% were blue, right? In comparison to the P that they think, which is 0.24. That's the other P. All right? Square root of, now do we use 0.27 or 0.24? We use 0.24 on the bottom. Times Q then is 0.76, right? I think we did that one number already. And N is 100. All right, practice typing that in. Let's see what you get. .702. Really? Yeah, I don't think that's right. Is it? 0.702? 0.702. Okay. 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 0.702. Okay. All right. Good. Okay.
Bless you.
All right. All right, I'm going to tell you one more thing about our conclusion. And it is this. Ready? This is what we're getting toward, okay? This number right here that was our Z, 1.96. This is the cutoff for extreme values. Remember, Z or Z score is like how many standard deviations you are above the mean, right? So if you are higher than 1.96, you are considered to be an extreme value, right? Like if you are higher, like on a number line, if you are larger than 1.96, okay? Like here's my 0, like my negative 1.96 would be here. If you are higher than 1.96, that's considered to be an extreme value. This is considered to be extremely low value. The number that we got was 0.7 something. Right? Right here. Because we are comparing 27% to the 24%, right? 24% is the average right here, what they're claiming. And 27% corresponds to a Z of 0.702, right? So if my 27% would result in a number for a Z that was higher than 1.96, what does that mean?
It's inaccurate.
They're lying about their 24%, right? But is 27 close enough to 24% to say that, okay, they can get away with saying 24%, right? Mm-hmm. According to this, yes, because the extreme cutoff is 1.96. Does that make sense? This is what hypothesis testing looks like. Are we hating this already?
Yep.
Yep. Okay, so here's the deal. I don't care. You can be truthful with me. It will get better because you will know what you're doing later on, okay?
That's
So,
what they all say.
all right, sure. So, well, I think it got better for everybody except you,
Well,
TJ.
no,
So you
that's
can't
cool.
vow.
No,
I
it
mean,
did
we
get
can't
better.
go by your
No,
stuff, all right?
Sorry.
So anyway, all right. So here's what I want you to do. Ready? Woo. Okay. Let's go to. You guys have a homework sheet, and I'm going to give you a couple homework problems to do. Oh man, where is my homework sheet? Are we getting dizzy yet? Here we go. Oh. Homework sheet looks like this one, 8-1 review. Okay, what I'm going to have you do is I'm going to have you do 1 through 4. And all you're doing is finding the test statistic. That means plugging the numbers into the equation. So here's the deal. Number 1 says most adults would erase all of their personal information online if they could. A software firm surveys of 636 randomly selected adults showed that 65% of them would erase all of their personal information if they could. Find the value of the test statistic. Is this a proportion, a mean, or a standard deviation? Given the information that they give me. Why? How do you know it's a proportion?
Percent.
Because there's a percentage in there, right? 65%. That tells me I'm doing a proportion. So right proportion next to this. Number 2, fewer than 91% of adults have a cell phone. In the reputable poll of 1017 adults, 83% said they have a cell phone. Find the value of the test statistic. That's a proportion again. Okay? Now, this is a little bit confusing as far as P and P hat go. Okay? P hat is the sample, P is the population. Okay? P hat is the sample, P is the population. So on number 2, where does the 91% go and where does the 83% go? 91 is population. So 0.91 is P. And according to my sample of 1,000 people, that's 0.83, that's P hat. Okay, so that can get you a little bit of a start, all right? So just distinguishing between the two. Number 3, the mean pulse rates. It's probably going to be a mean that we're doing. Number 4, the standard deviation of pulse rates. It's probably going to be a standard deviation. So what I want you to do for homework is those 4 problems, pull out the information kind of like we did with the P and P hat, okay? And use these formulas here. I'm making them dizzy. I'm making you dizzy. Right here. Use this information to figure out what your test statistic looks like. Those are some tall orders. You're just putting the stuff in there and you are solving for the test statistic. You're just plugging numbers in. Come
I
on.
have a question though. For number 1, how do you find P hat? Or what's P hat and what's P?
What's P hat and what's P? Do they give you? They give you?
You have 65%, then you subtract it from 1, right? Or 100.
To find Q.
Find Q, yeah.
Right.
I need P. P is the,
Okay. Most adults would blah blah blah. A software firm survey of this many selected adults showed that 65% of them would erase their personal information online if they could.
0.65 is
Oh, I didn't tell you that.
P-hat.
P-hat. P-hat is 0.65. I lied to you. It says most. What is most? What does most mean? What does most
than
mean?
50.
More than 50%. So, P is going to be, good call, Maddie. P is going to be
greater than 50.
50% or 0.5. Good call. Yes, when they say most, use 0.5. Holy cow, that's a lot of stuff. Okay? All right. Use those formulas, plug stuff in. These are some tall orders. You might get a little confused. It's okay. Do we know what we're doing?
Yep.
Just 1 through 4, the formulas.
I understand.
TJ, I'll come help you.
No, yeah, I don't need it.
Okay, all right. Okay,
Wait, no,
all
I'm
right.
kidding.
Goodbye, people in the video. Maybe if I can cancel out of this. I don't know. Video recording, stop.